Hello everyone, and welcome to another video in our series of Texas Instrument Calculator and how to use the BA2 Plus calculator. In this series, we're going to cover a variety of topics on how to use the BA2 Plus calculator for financial or business math.
In this video in the Annuity series, we're going to be looking at the compounding and time period, how many payments or how long it will take for annuity to be paid off or paid back. Using the BA2 Plus, of course, calculator. One more time, remember that we have 4 types of annuity based on whether the payment is made at the beginning or the end, and whether the compounding and payment periods are the same or different. Similar to what we did with the PMT, finding N or T in this case is a little bit challenging because you have to figure out which formula to use for future value or present value, whether it's future value or future value for the annuity due, present value. We have to divide and move things around and get N out of the power. The only way to do that is using the logarithmic function. So it's a lot of work. Same with the present value. That's why the calculator is our best option. So let's look at the first example. RRSP 18% compounded monthly. How long? So we're looking for T here. How long? Rounded up to the next payment period. Will it take for the funds to grow to? Another thing that now makes things a bit harder is that we're looking for N, yes, but what's given to us? Did they give us PMT and future value, PMT and present value, or present value and future value? So here to grow to, that means this is the future value based on annual year-end contribution. That's the PMT. Then it's year-end, because we have to figure out the annuity, monthly, year-end. They are not the same. Compounding period and payment period are not the same, and it's at the end, not at the beginning. So make sure the calculator is set to end mode. Of course, we're looking for N. Interest rate is 18, PY is 1, CY is 12, because it's a monthly compounded. Present value is 0, PMT is 3,200, and the future value grow to 385,000. Pressing the CPT on the calculator, you will get N is 17.911. They said round up to the next payment period, so that's 18 payments or 18 contribution. Now, here we have to be extra careful because depending on the contributions, here it's yearly contribution. So 18 contribution per year, that's 18 years. But if it was semi-annually or quarterly, remember T is N over M. The payment frequency here, it's 1. But in other cases, it will be either 2 or 4 or 12, so be careful with that. And the answer will be 18 years. Let's bring the calculator and see how we enter these values and get the same result. So make sure to set the calculator to end. You can see here it's set to begin, so we're going to press on second, PMT, then second, set, then second, quit. Interest rate is 18. Present value is 1. Sorry, PY is 1, so we have to go to PY, enter it as 1. Go to CY, enter it as 12. Then quit. And the present value is 0. PMT is 3,200, but it's a payment, so it's a minus. And the future value is 385,000. And that's the future value. Now we press CPT and you will see that the answer is indeed 17.9114. Rounding to 18, divide by 1, that's 18 years. Similarly, for the annuity due, we have lots of work to do. The only difference is we have that extra factor, the 1 plus I, so we still have to divide, move things around, multiply, take log, drop the power, divide again, lots of work, whether it's future value or present value. You can see just to enter these values in the calculator, if we're using the formula, not using the financial calculator, it's a hassle. Luckily, we won't be doing that. So let's look at this example. Lottery, 38,000, and he deposited the money. So that's present value. Because he won now, deposited. Earning 6.4 compounded quarterly. Withdraw 2,000 at the beginning of every 3 months. So withdraw 2,000, that's the PMT. Quarterly, every 3 months, means compounding period and payment period are the same. But it's at the beginning. So make sure you set your calculator to begin. How long would the money last in the fund? Okay, so set to beginning. Interest rate 6.4, PY and CY are 4, present value 38,000. It's going to be withdrawing 2,000 every month, every quarter, till there's no money in the fund. How long it's going to take him, how many withdrawal he can make? 22.39, rounding up, that's 23 withdrawal. But it's every 3 months, so how long? How many years in months? We have to divide this by 4 because it's every month, 3 months or quarterly. So there are 4 payments a year. This will give us 5.75 years. We're going to take the 0.75 and find how many months are that by multiplying by 12. And of course, that will give us 9 months. So it's going to take 5 years and 9 months or 23 withdrawals. One more time, let's bring the calculator back. And we have to set the calculator to begin. So one more time, we're going to click on second, PMT, second, set, then second, quit. Interest rate is 6.4. We're going to go to the PY and CY, and both are 4, so we press enter just to make sure. CY is also 4. Quit. Present value is 38,000, the amount of the lottery that you want and deposited. Withdrawal of 2,000 till there is no money on the account. How long it's going to take? We're going to press CPTN. And you will see that it is 22.39922, rounding up to 23, and so on, dividing by 4, multiplying by 12 the decimal to figure out the number of months, and the answer will be 5 years, 9 months.
Thank you for watching, and don't forget to subscribe to my channel for more videos on statistics, using SPSS and Excel, among other things.